In this video, we're going to do a third really basic limit example. So we're going to find the limit of a function, f of x. In this situation, we're asked to find the limit as x approaches 2 of f of x. And f of x is defined as 3x plus 2 divided by the quantity 2x minus 4. One of the first strategies we always want to employ when we talk about finding limits is considering the graph. And this will be some good review for us. Let's graph this rational function. So you should know all of these skills from your prior algebra class, but we were able to identify horizontal and vertical asymptotes as well as an x and y intercept. Now the horizontal asymptote comes from the ratio of those leading coefficients, since both the numerator and the denominator are the same degree. They're both linear polynomials. We've got that ratio y equals 3/2. The vertical asymptote comes from setting that denominator equal to 0 and finding the undefined value. And that's going to give us x equals 2. The x-intercept comes from setting the numerator equal to 0. And then the y-intercept comes from letting x equal 0. We end up with negative 1/2. So you should be able to pull each of these four pieces together pretty quickly, but of course you always have your graphing calculator as well. So in this problem, now that we have our graph, what are we looking at? We're looking at the limit of the function f of x as x approaches 2. So if I were to trace along my graph and approach 2 from the left, I notice that we're going down forever to negative infinity. And if I consider approaching x equals 2 from the right, I'm going up forever to positive infinity. So I'm going to introduce some new notation that you don't necessarily need right now, but we're going to be building towards. We'll say the limit as x approaches 2, I'm going to put this little superscript negative from the left of f of x. And as x approaches 2 from the left, where does my y value go? Y goes to negative infinity. So this value is negative infinity on the left. And then we'll also say, well, let's look at the limit as x approaches 2 from the right. A little superscript plus indicates right of f of x. And what does that equal? And as we travel along the graph towards x equals 2 from the right, we notice that my y values, y is going to end up approaching positive infinity. Of course, you don't need to write a plus in front of the positive. I'm just writing it here for emphasis. Now, do the left hand and the right hand sides match? And the answer is no, they do not. So in this situation, we are going to say that the general limit as x approaches 2 of f of x does not exist. We're going to write D and E, okay? So when the left and the right hand limits are not the same, when we're not going to the same number from both sides, that's a situation where the limit doesn't exist. Now, I do want to clarify, we will have situations where, say, we're looking at some value, and maybe as x approaches 2 from the left and as x approaches 2 from the right, you're going to notice that both of my values in this graph are going up to positive infinity. Now, infinity doesn't exist, but this is a direction. This is something we can say. So we don't say does not exist for this limit. We would say goes towards positive infinity. And we'll have more examples, more practice with looking at those limits. All right, so I hope that helps you understand. The main thing we learned here is we can find that limit by considering the graph of the function. And then we're saying, well, if the limit on the left and the limit on the right don't go to the same number, then we answer the problem and we say the limit does not exist, DNE. All right, please feel free to reach out if you have any questions or concerns.